everyone, welcome to the another episode by Tech Talks by Technophiles, podcast brought to you by Computer Science Department of Bharati College, University of Delhi. I am your host Sanjana Nayak, and today we have a exciting episode lined up for a enthusiastic out there, especially those who are curious about world of machine learning and of MLOPs. As you all know, MLOPs is where the magic happens. It's where DevOps meet backend development and machine learning, creating seamless ecosystem that powers some of the most innovative solution in tech today. So, help us to dive in this topic. We have a very special guest with us, Raghav Awasthi. Raghav is a senior full stack engineer at Ola. He is very he has been a key planner in developing Kiritum AI and cutting edge venue at pushing at boundaries of AI and mobility. He's also worked with several startups, contributed to open resources projects, and he has rich background in both Android development as well as MOPs. Raghav, we are thrilled to have a one show today with you.
Hi. Thank you, the entire Technophile Society, as well as the team, for inviting me. So it's something you could say a mix of not just plain machine learning or DevOps. It's something like a mix of multiple background streams. So you could simply assume key. Let's say you are building any basic LLM model. Okay, and those are the ones that are in hype right now, right? Something like ChatGPT or something. So end of the day, it's not about just putting out your model somewhere. You also need to manage how it scales. So scaling is what essentially is the key component that created the entire MLOps domain. So let's simply assume as an example. Let's say you want to build a tool so that any of your freshers, you want to know, okay, like how's a curriculum look like, or whom to reach out for something. So you could have a simple sort of a RAG setup, or we call it a RAG pipeline. So that would involve your backend. You would need a front end. You would have a ML model, which is a part of the pipeline. But how do you scale this out? That's where this essentially comes into picture. That's one interesting thing. Apart from this, you could say that there are a bunch of tools right now. Initially, when it started out, there were only a few repos which you could refer to, but now you have like bunch of them, which each having their trade-off. So, like the biggest problem with ML models is you have hallucinations. How do you counter that? So you're gonna do fine tuning on top of it. But again, the problem starts here. If you want to fine tune, then how will you get the infra, and how will you manage your infra at that scale? You cannot get, let's say, 1,000 H100s or E100s. There would be errors, right, as a normal system application. So how do you make sure that when the error happens, your system is like resilient to that? That's like more about MLOps journey. And one thing that I would say, like if you're starting off with MLOps, focus on the core fundamentals, the basics of your networking. That's gonna go a really long way. Your standard HTTP protocols, how do they work? How does connection negotiation happens? Because the moment you start building models, since LLMs are slow, you cannot have a response immediately. You would often want to stream it out. How would you want to stream it out? Do you want it to be a service sent events? Do you want to be it like a gRPC packet or anything? That's where your computer networks are gonna go a really long way. Then MLOps also touches your database fundamentals to a great extent. So let's take a use case. Your average ML model will take, let's say, roughly 3 to 4 seconds for some query. You will not want to call your actual model each time. You want to have some sort of indexing or some sort of a vector storage. Like that's what you would call it out. And then your vector DBs come into picture. So how would you plan that out? Again, there are various strategies around it. So that's where your DB fundamentals will go a long way. So that's one thing. And then you have your core infra. That's where your combination of these things will come into picture. Eventually, most of the ML workloads, they run in Kubernetes these days, right? So that's where
Yeah,
your things get a bit tricky. Kubernetes will
it's
have
very
issues
interesting
putting.
to listen all these things which come up from you. Like it's legit showing us the roadmap, like how we can start with the things. So, so how you're actually pursuing all this thing, like how you have to get it started with these. What's the initial phase where you started it?
So, to be honest, I started off as an Android engineer, and like most of my initial tasks were key. Let's say DS team has built something. DS is referring to data science team. So they have built some model, and we have to push it onto Scooter. So that's how the journey started. The initial model was like, if you have, by any chance, use Ola Electric Scooter. So if not, then I'll just work it out. There's a feature like called proximity unlock. So you can just keep your phone in your pocket and just go near to your scooter to unlock for you. It's pretty simple for normal vehicles, but in case of electric scooters, we had custom chips and all. So we use a model there. That's how I started off with the journey. So the initial version was like, okay, we built a model, push it out. Then we were like, okay, how do we manage the updates? We cannot roll out an Android APK update each time. There has to be some pipeline which will like automate this flow. So we built pipelines around it. After that, I moved on to you can say Ola Krutrim, like the initial founding team. So initially we were around like a very small team. So we were like, okay, everything has to be built up from scratch. And yeah, initial things you make a lot of mistakes. We also did. We broke a lot of stuff. We had production outages, but that's there. And then I moved on to, you could say, the backend. Like I was already building backend pipelines for the mobile team for the model deployment. Like, hey, we're building this LLM for Krutrim, and let's build it. So that's how version 1 rolled out. We made bunch of mistakes, and we got a lot of mixed feelings from the community. Then we improved upon it, and like right now the pipeline is pretty much, it's quite smooth compared to what it used to be. Like from manual deployments to we have quite of automation around it.
Okay, so before we get into the nuts and bolts of MLOps, so let's start with something basic. So, Raghav, many of our listeners are familiar with machine learning and DevOps are as separate entities, but MLOps might be a new term for some of us. So, could you kick something off by explaining what MLOps is and why it's becoming such a crucial part of modern tech ecosystem?
Okay. So to be honest, MLOps is a fancy term which the community has given. Essentially, it's your plain DevOps, and you just are putting your model backend on top of it. The only change here comes into picture is कि initially DevOps used to just care about कि hey, my application will consume how much RAM, how much CPU. That's it. In case of your ML applications, you are also concerned with GPU. In case of GPU, it is very much specific to your specific model. You cannot say कि one solution works for all. that's where your knowledge of machine learning along with DevOps comes into picture. And so therefore the core CS fundamentals, they go a really long way here.
Okay, that's a great overview. So now when we talk about MLOps, we are really looking at the ecosystem that involves a lot of moving parts, everything from data collection and model training to deployment and monitoring. So could you walk us through the key components of any of like an MLOps pipeline and how each one plays a role in ensuring the success of machine learning projects?
So the first thing that starts with is how you get your data. So often, let's say you're downloading some terabytes of data. You don't want to do it on a single machine. You will distribute it, right? Then how do you orchestrate it? Let's say you are running some 30 machines. One of the VM goes down. How do you recover from that error? That's one thing. That's something you as a DevOps would think about it. So, but since you are building something around ML applications, you have to think like an ML engineer. So you cannot simply go and download everything, right? A normal engineer, what he will do, he will pull everything out of the cluster or let's say data source and dump it somewhere. But since you are an ML engineer, you would say, okay, I'll check whether this data is okay for me or not. By checking, I mean you would basically apply some sort of filters. In ML, you have like Bloom filter is there. Then you have like C4 pipeline is there. So what sort of filters you want, you basically apply those. My filters could be, let's say you are building an application that is for fintech use case. So you want to restrict your data to that. But your actual corpus may contain anything, right? So that's how your data ingestion starts. That is your first stage, how your data is getting into the system. Second thing, this cleaning wala phase. How do you further refine your data? Again, this will be running on a cluster of machines. So how does, let's say you are running your data download process on, let's say 30 machines, but you want to run your cleaning process on over 100 machines. So you can have ups and downs there, right? So how do you connect these two data, pipeline components? That's one thing. One thing is this. Other thing that comes into picture is how do you store this data efficiently? Do you zip it? Do you create a tar out of it? Do you create a Parquet out of it? These are like data formats. So which one will be more efficient for your use case? So generally in ML ecosystem, we prefer to use Parquet a lot. Parquet is like a optimized format for your data storage. And like that's also something which we heavily use here as well. And yeah, that's one thing. The third component, again, how do you train your model pipelines? How you train your specific model. Then you have your task on which you want to specifically train your model. That's there. So as an overview, you have your data ingestion, you have your pipeline cleaning, you train your model, you deploy your model, and then you monitor your model. These are the primary components.
Awesome. It's clear that MLOps is not just about managing models, but also about integrating them into a larger system. So you have worked on building MLOps pipeline at Ola, especially for the Krutrim AI project. Could you share some real-world example or challenges you faced while setting up these pipelines?
The biggest thing that we did face was how we ingest the data. We were swarmed with it. We ended up paying huge infra cost as well. We had a glitch, we would say, or a misconfiguration. So that was one of the learnings we had. Then we had set up our own clusters to do distributed processing. We use a sort of automation on top of it. We tried multiple approaches. So at Ola, it's not fixed key, only one thing works. We have like plan A, plan B, plan C, whatever works. And we execute that in parallel. And that's one of the key differentiator. Like we're able to deliver everything faster. So that's there. So we built a distributed pipeline, and the like I will not go into details of it. Like a few things can be disclosed, you cannot be, like NDA restrictions and all. So the things which we did, we had you can say a Ansible based setup. Ansible is like a tool for automation. We use that to set up our machines, provision them, execute our data now, processing scripts, and then we ingested it into our models. So even for training pipeline, we have our own cluster. So we had used our infra for it, and that was interesting and most challenging as well. It's challenging in the sense since it was new for the entire team. So you have to onboard folks, and at the same time you have to deliver stuff. So a mix and match of in that direction. So that was mostly a key. Like nowadays we have a bunch of really efficient tools. Like one of them is Data Trove. You can check that out. It's really efficient for these data cleaning, and it's way more organized. So initially, we also built something similar, you could say, but Data Trove is something that is open source, so you can try it out. They also have their entire common crawl pipeline. Common crawl is like one of the dump where your entire internet data is collected. So it has its archive. You can just download. It has some petabytes of data, so you could like pretty much use it to or pre-training. Mostly be fine-tuning it. In that case, you can check out Hugging Face. Hugging Face has pretty good data sets that you could use in your college projects, and it will come in quite handy. Then for building your MLOps pipeline, you could use tools like Haystack. It's really elegant solution. Then you also have some alternatives. Langflow is there, LangChain is there, LangGraph is there, like a bunch of variations. Everything has a pro and a con, so you can decide accordingly. For us, like we were using mix of tools for different components, so it's not one solution fits all again. So it's use case to use case.
That's really insightful, and I'm sure our listeners, especially those who are aspiring to get into MLOps, are wondering about the tools and technology involved. From your experience, what are some of the must-have tools for anyone looking to set up the MLOps pipeline, and how do these tools help you to interact with each other?
So one thing that I would highly recommend is get your hands dirty. That's the uh, beginner 01. So just get started. Like there are a bunch of you should not be worried about key if I have a GPU or not. Just go to Google Colab. It gives you a T4 GPU. It's pretty much good for your basic pipelines. Just get started with it. Most of the like documentations already have their own like tutorials or cookbooks around it. Just build a basic chatbot. That's how you could start it, and then start integrating other components. Components could be like you can use something like Flowise. Flowise has a pretty good orchestrator for it, and you do not have to write code. So though I would recommend to write code yourself, but you can try Flowise and just see how things work. Then you can go around implementing those things by yourself. That will give you more insights on, okay, I know like what the system is. Now I know how the individual components work. Flowise has a drag and drop UI. So you just say, hey, I need this pipeline, I need this component, just drag and drop, and it's like a no code tool. You could use it out of the box. But once you start writing a pipeline from scratch, you get to understand what is like that, why. This why is really essential. And that's where your optimizations will come into picture. So being a ML engineer, one thing that's always there, it's how do you optimize your infra. You do not want to have 8 replicas running for something that can be done in one replica. Replica is like number of instances. So like you are paying like roughly, in case let's say you take a G5 machine from AWS, it costs like $5 an hour. So you do not want to spend some $40 an hour just like that, no. Oh yeah, that's that.
So it's very fascinating to see how these tools come together to create a robust MLOps framework. Now, shifting our gears a bit, let's talk about the collaboration aspect. So, MLOps often requires close cooperation between data scientists, developers, and operations team. So, what strategies do you recommend for fostering effective collaboration among these groups, especially in the fast-paced environment like Cola?
So one thing that always gets in blocker is how do you communicate your data science team's knowledge to your engineering teams, right? How do they, like, they won't be able, they can't, they generally at teams you have a mix of folks, then it works. But let's say in case of few startups, you might have a completely isolated data science team or a completely isolated engineering team. In that case, you would need to have someone who has hands on both sides. That is what a ML engineer or someone who works on MLOps does. So you know how models work, you know how they should be deployed. Then you also know how your engineering team is going to use it. So engineering team, I refer, let's say your backend team, right? They don't know how a model works. They would say, hey, give me an API which accepts something and let's say gives me out. So this is your role as an MLE, to be able to translate, or you could say bridge the knowledge gap between both the teams. So we use tools like MLflow. It is where you basically register your models once they are trained and you share with your engineering teams. You could also use something like a DVC, that's basically for data organizing, but generally it's a trade-off. So most of initial startups will not have a DVC kind of setup initially, but eventually you will get into a place where you need it.
Great advice. Collaboration is definitely key to making MLOps work seamlessly. Speaking of fast-paced environments, the tech industry is constantly evolving. What trends or future development in MLOps do you think we should be keeping an eye on? And how can young tech enthusiasts prepare themselves to stay ahead in this field?
So I would say the industry is changing very rapidly. Like every 2 or 3 months, we see okay, we have been, let's say, using something, and okay, we have got something way better than this. Let's ditch that and migrate to something else. So you have to keep your applications that generic key. Let's say you want to remove something, you should be like, okay, done. So that is one thing. Then keep on reading. Like basically what we do is we read a bunch of research papers. Like we have dedicated hour slots around it. So like folks from the team would take out some research paper, someone would study it, implement it, and then he would be giving a workshop to the entire team. So, and this happens in rotation in the entire team. So this way, everyone gets to know. Like let's say hypothetically, let's say you have a team of 8 folks. Each 8 individual is reading some different research paper on some other topic, and then let's say every bi-weekly, let's say Monday and Thursday, you are doing those sessions. So now your entire team is able to get a huge grasp on those stacks. They're not being overburdened as well, but they're also learning and being updated to the industry standards. This is something that could be implemented at college level as well. You could have your friend groups. Okay, let's like you could divide your. I guess you must be having your DSA practice sessions in a group. Like I used to have those in my college days. So something like that you could do with ML papers. And That's one thing. Read a bunch of articles, follow a bunch of folks who uh, post about it, and yeah, sorted.
Yeah. So, how important is project building? Because our uh, teachers and the ones we have talked about, the industry experts, they always say make more and more of projects, work more, do practice, and like just do more and more of projects. Like, how much percentage of weightage does project holds in cracking any of the companies or interview or showing shortlisting in that?
I would say doing more and more projects is actually not a good thing. Doing one project that explains your skill sets is good enough. Like you can do multiple, there's no harm in it. But let's say your single project is good enough. So there's nothing like end of the day for a company. All what we care is ki, how do you let's say I'm spending X rupees from you. How do I get 8x from you? That's a simple maths, right? So when we are hiring for, let's say, our team, so we'll be looking for, okay, some does that person know how to work with KTS? Does he know the fundamentals? That okay. Second thing that will come into picture is does he know a bit of your backend applications and all? And like these are the two things that we definitely look for. If the person has an exposure with Kubernetes, Docker, any container runtime, it could be, and your basic ML applications, he knows like what are the basics of an ML. You do not need to be an expert at it, but you know the fundamentals, and the fundamentals should be really good. You know how your computer networks work. That's the first thing I mentioned. So because a lot of things, when the things break, things come down to, okay, why is this thing choking? So um, like you must have heard about TCP SYN flood. That happens. So if you are not good at CN, then you will not be able to identify it. Then you also have concepts around host names, routing. Let's not go there. It's a whole detailed stuff. So yeah, projects matter, but a single good project is good enough. You just have to show your skills. That's it.
Fantastic. This conversation has been packed with valuable insights. Before we wrap up, Raghav, any final thoughts or advice for our listeners who are eager to dive into the world of MLOps?
So like I would suggest is break things and keep yourself updated. Things are changing real fast. Build your portfolio. Let's say you build a chatbot, put it out on Twitter, put it out on LinkedIn, and you can host it on anything. Uh, there are bunch of like do not in let's say you are a hardcore ML engineer or a backend engineer. Do not think about investing too much time on front end. Use tools like Gradio. It gives you a basic minimalistic UI, and that's good enough as long as you are able to showcase your like fundamental skill. It's okay, right? You can just put it out on one thing that I would highly recommend is do cold emails. Let's say you build a good project, reach out to folks, just email them. A lot of time companies do not post job openings, but they do have it. So let's say you reach out to the specific team's EM or something. Your resume will be processed much faster. And most of the cases, the job opening is does not even get published to the general audience, and the folks are already filled for that position. So cold emailing is very effective. Like in case, even in my team, I've hired a bunch of folks, and it will like just, yeah, someone randomly sent an email. We saw that project is good. We checked the resume; it's good. We forwarded it to the team, and he's here. So yeah, that happens a lot.
Thank you so much, Raghav, for sharing your knowledge and experience with us today. I'm sure our listeners are walking away with much clear understanding of ML loops and how they can start exploring the exciting field. And to our listeners, thank you for tuning in. If you enjoyed this episode, don't forget to subscribe, leave a review, and share it with your friends. Stay tuned for more exciting content from Technophiles as we continue to bring you the latest and the greatest from the world of technology. Until next time, this is Preeti signing off. Stay curious, stay inspired. Thank you, everyone.
Thank you, Files, as well, for hosting me on the show.